Hey guys, welcome back to the channel and welcome to day 4 of Python library series. And today I'll be discussing some interesting libraries which is very useful for image processing, and if you want to learn advanced image processing, in that case it's very interesting and very helpful. Okay, and I'm talking about the library that is OpenCV. Okay, there is a library in Python which is OpenCV, which you can install with the help of pip install opencv dash python. You can write this off in your terminal and you can install the library opencv before you start working with it. Okay, now in today's tutorial, what we want to achieve with the help of opencv, first let us know that. Okay, so what our output should look like. So I have something like this which I want to achieve. So basically this is my original image, how it is looking, just look at it exactly. Okay, and like blue and yellow color is being used and Python is written. So I want this to be converted into this. Okay, that means my output should look like this is my output. Okay, this one is my output. So how it should look, it should have a gray edges, okay, from this particular input. Okay, and the Python also, I don't need the color, only the gray edges I want, and the background should be all complete black. That means in the input, if you are giving a image, I want a gray scale image, but the condition is I only want the edges of that particular image. I don't want what is there inside the image. I mean, I don't want the colors or anything. I just want the edges to be gray for this particular image. Okay, now how to achieve this? With the help of OpenCV2 as well as matplotlib. Now why matplotlib? Now if you see, I want it in two, okay, if you see the image, I want it in two places. Okay, that means it's actually dividing it, the whole screen, into two parts, right? So for that I want a matplotlib, so that I can show the original image in my first part and I can show the edges image, that is the edges detected image, in the second part. Okay, now see what you need to achieve. First of all, there should be you can call this as like the title. So there should be one title which is original image and the other title would be edges detected. Okay, next you have to read the original image first of all. So you can take whatever image of your choice. I am taking this image. Okay, so first of all you have to read the image and then show the image. Okay, first thing for the original image. Next thing, you have to work on how you can convert this particular image into a grayscale image, and then you actually detect the edges, because I only want the edges. Okay, that's the part. And next, towards the end of the code, you have to just plot it using the matplotlib library. How do you plot it in the same screen? Like, we can use the plot subplot function, and here we can write, suppose this particular part is like a 1 2 1. Okay, so how you plot it, like if it's like this, so this is 1 2, so quadrant wise. Okay, first quadrant, second quadrant, third quadrant, this is 1 2 2. Okay, because it's a second quadrant. Okay, this is 1 2 3. Okay, because it's a third quadrant. So this is how it works. So using subplot, you can make it like two images in one screen. Fine, that is the reason we have to use matplotlib. Okay, now let's take a look at this again and let's go back to the coding and let's try to achieve it. Now if you see, this is not the output, this is just a snipping tool with the help of which I've just taken a screenshot for you guys to understand how the output should look like first of all. Okay, now let's get started. I'll close this. Okay, now here as I said, install OpenCV and then only get started. So first of all we will import. So now we have installed OpenCV, so we will import CV2 from it. Okay, so I wrote import CV2, and I also want to work with matplotlib, so I'll write matplotlib dot. Since I want to work with the plot, so I'll write pyplot and pyplot as plt. So I want to inherit the function of this particular library, which is plt, which will help me to show the plotting, right? So if you go back to the previous video which I have uploaded regarding the libraries, there you can see how exactly matplotlib works. Okay, the day one, you can check that out. Fine. Now let's go on to the second part. Now that we have imported the libraries, which is essential for the output which we want, first we have to read the image, right? So I have the image name as 04.png. You can take it in any other form like jpeg, png or jpg. Okay, so I'll take a variable, let's say image, and inside this I'll just read it. So now you have to read it with the help of cv2, okay, because you're using OpenCV. So I'll write cv2 dot I am read. Okay, that means I am read is a function from cv2 which will help me to read my image. Okay, and inside this I'll just write the image name, so that is 04.png. okay, done. Now next part comes up, so let me just comment off so that it makes easier for you. So next part comes up, I have to convert it into grayscale. So grayscale conversion. Okay, now how do you convert it to a grayscale? So let's say I take a variable gray image, okay, and inside this with the help of cv2 itself, so you'll write cv2 dot cvt color. Okay, so this is the function from cv2 which will help you to convert your original image into a grayscale image. Okay, now question can be like, why don't we directly, convert the grayscale image like we did it in a previous class? That can also be done, but since we have to find out the edges of our original image, that's the reason why we are taking into an advanced image processing technique with the help of OpenCV. So which will make your task easier. So we'll write cv2.cvt color, and inside this I'll write first of all the variable name in which I have read the image, that is image, and then give a comma, and then after this I'll write cv2 dot color underscore bgr to gray. Okay, that means it will be converting my original image into a grayscale image. Okay, now I have converted my original image into the grayscale image with the help of this coding. What we have to do next, we have to now extract the edges, right? So next part of this coding would be, I have to detect the edges. So detecting the edges of any particular image, if you're using an OpenCV, then I would suggest go for the Canny detection. So it's called as Canny. Okay, so detect the edges using Canny. So this is another functionality which you can take it from the library, that is OpenCV. Okay, which will help you to actually extract or detect the edges of your image. So how to do that? So let's say I take a variable edges, okay, and inside this I'll write cv2 dot, now I'll use Canny, okay, so I'll write Canny, and then inside this I'll write this particular variable name in which my grayscale image is there. Okay, so here I'll write gray image, and then I'll mention the thresholds like how it should be. So I'll just mention like 100, 200. Now this you can change it according to your image. Okay, these are the threshold values which will help me to detect the edges of this particular image which I have, that is which I showed you in the start of the tutorial, and it will be stored inside the variable that is edges. Okay, so now three parts of the coding is done. First is we have read the image, on which image we have to work, that is 04.png. Okay, next we have converted this particular image into a grayscale image using the CVT color functionality of the CV2 library of Python, and next we have also detected the edges using the Canny functionality of OpenCV. Okay, these things we have done. Now what we have to do, first of all, we have to display both the images, right? The open, the original image as well as the edges, right? So for that, what we can write, so display original and edges. So for that, let's write, or let's use the function of matplotlib, that is plt, and I'll just write plt dot figure, and inside this I'll write figure size equal to, let's say I give the values, the threshold values as 10,5. Again, you can give your own values over here according to the size of the image which you want. Okay, so basically this particular coding, what it will do, it will actually help me to divide the screen of my output into two parts, and it will display the image according to the size which I have mentioned, so according to the threshold value which I mentioned. Now almost 80% of the coding is done. Now what we have to do, we have to only plot our images. Okay, so for that, first of all, we'll write plt dot subplot. Why subplot? Subplot is being used in order to make sure that two images comes up in the same screen. That means dividing the quadrants. So first quadrant, so what value I should give? 1 2 1. That is my first quadrant. So what should be there in my first quadrant? So in my first quadrant, I want the original image, so I can write plt dot, let me give the title, so can be original image. Okay, and now I want to show that image, so for that, what you have to write? plt dot im show. Okay, and inside im show, what you need to write? cv2 dot cvt color, and the same thing which you have done in the here, the gray one. Okay, you can write like this, image cv2 dot. Okay, this is what we wrote inside im show. That means this particular command or these actually will help me to subplot my screen wherein I want to see my output. So first part, it will show the original image, it will have the title as original image, and with the help of im show, it will show me the original image. Okay, now next, what we have to do, we have to go off with the edges detected as well. That image I also want to show. Okay, so for that, first of all, now I have to turn on my axis, because for first image my axis is done, the x-axis, y-axis is done. I don't want it, so you can write plt.axis and you can turn it off. Okay, now you can write plt.subplot, and inside this, second quadrant means 1 2 and then 2. Okay, and then now move on to the title part. So you can, what you can do, you can just copy this off, so here, and just you can just change this edges detected. Okay, fine. Now I want the edges to be in gray color, so for that, what you have to write? plt.im show, and inside this you will write edges. Edges means this particular variable wherein your grayscale, edges is being detected and extracted. So edges, that variable name, and then camp is equal to, now I want the linings in gray color, right? That means my edges should be in gray color, so I'll write gray. Okay, this is done. Now I'll again turn off the axis. Okay, and at the end I'll write finally I want to see it how it looks like. Okay, now our whole coding is done. So now we are done. Now what we have to do, we just click on file and then click on save, and then I go to my terminal. Okay, now over here I'll just try to run. So the name of the file is pd.py. So when I write python pd.py and press enter, now this is what we exactly wanted. So in the beginning of this particular tutorial, you saw what we were trying to achieve, and we have achieved now. This is what we wanted, and this opened up in the terminal itself. So this is the original image. This is how it looks like, and after performing the advanced image processing with the help of the library OpenCV along with Matplotlib, we have plotted these two images in order to see what is the difference. Okay, so this is my original image, and this is what we wanted, that is the extraction of the edges, and it should be gray in color, right?